All right, hey everyone, this is the short recap for week 33 of my chill kernel hacking for fun streaming. This week we got into multiprocessor boot up, or like implementing the startup process for multiprocessors on the system. But that's not what I did immediately. I was initially just wrapping up lab 3 from last time, just running the tests. I do that for a couple minutes. And then around the 4-minute mark, I start reading into lab 4, preemptive multitasking. And I'm just kind of reading the lab a little bit. Actually, I spent a little bit of time resolving merge conflicts because I need to take my lab 3 branch and merge it into the lab 4 branch where they've added a bunch of extra code for multiprocessor support. So I spend a bit of time just resolving merge conflicts, and I finished that around the 10-minute mark, maybe around the 12-minute mark, I suppose. Yeah. Okay, nice. Then basically I do a little bit of a tour through the new code that we have in the repo. It's all these new files, and just kind of go through and read a bunch of code. All this new code for multiprocessor support. Reading through the assignment. Just a bunch of learning, basically. This stream was a lot of just learning new stuff for me. Not a ton of writing code, but a lot of, I would say, very valuable learning about key aspects of multiprocessor support, like local APICs, the startup process from the bootstrap processor to the application processor, sending IPIs from one processor to another, that kind of stuff. I got to the first exercise, which is pretty simple. Basically, we need to have a way to map memory mapped IO regions from physical memory and place them somewhere in our virtual address space that we can write to them. Because currently in our virtual address space, we have a direct map of the first 256 megabytes of physical memory, but a lot of these MMIO regions are far beyond that, and so it seems like actually for a lot of these local APICs, the memory mapped IO regions are really high in memory, close to the end of the 4 gigabyte physical memory mark, and so we need to explicitly map those into memory. We cannot rely on our direct mapping. So that's the first exercise, and that's what I do from the 24-minute mark or so. I'm kind of reading about the call, like the usage of this function, and then I just kind of implement it. It's not too difficult. Just doing some balance checking, calling some functions for mapping memory, and that's pretty much it. So I'm done with that around the 33-minute mark, and from that point on, just fixing some bugs, some like compiled bugs, simple stuff. And from that point on, it's pretty much just a lot of reading about this whole application processor bootstrap process. And that's what I do from 37 minutes to the end of the stream. A lot of reading, a lot of learning, going into the manual to try to find out the authoritative documentation about local APICs and that kind of stuff, which is in chapter 11 of the recent Intel manuals. Looking at how the bootstrap processor reads information from the BIOS, using legacy BIOS to learn about all the different CPUs on the system and information about them, like their APIC IDs, stuff like that. Then just reading more through there. Reading about how the bootstrap processor actually boots up the APs, how it kind of copies code that they're going to execute for their boot process, and then how it goes and triggers the startup process. And then that's what I kind of really dive into for the last probably like 20 minutes or so, really diving deep into how you actually use the local APIC to start up a CPU. And it's extremely esoteric. It involves all these memory mapped IO registers and doing things in a very specific order with some certain timings. And I just go into that. I'm reading the Intel manual. I'm looking up this thing called the Multiprocessor specification, which is a separate document that describes a lot of this stuff. So just cross-referencing the code with the multiprocessor specification. And that's pretty much it. And so you can go into those details if you want, but that's the entire rest of the stream. Just learning a lot about these local APIC memory mapped IO registers, how to send IPIs using the local APIC, stuff like that. So that's it. That's the short recap for week 33. Thanks a lot for watching, and I'll see you next time.